This episode of Photonics Hot List is sponsored by Metallark Optics, where they take on what others won't. Challenge accepted.
Hello, I'm Justine Murphy, Senior Editor of Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Unnaturally adulterated food is unfortunately more widespread than most people realize. Even natural foods like honey are not immune. But researchers in the UK are shining a light on the problem, quite literally, in efforts to combat it. A team from Aston University's Institute for Photonic Technologies, working with the Scottish Bee Company, the British Beekeepers Association, and the UK's Honey Authenticity Network, are developing a technique they say could help in the fight against fraudulent foods, specifically honey. By nature, it's one of the purest foods on the planet, but adulterated forms of it have become the second most common example of food fraud globally. The new approach uses fluorescence excitation emission spectroscopy, a rapid, very precise imaging method, and machine learning techniques called parallel factor analysis and partial least squares discriminant analysis. This combined approach will help identify honey samples' chemical elements, assess the ratios of ingredients, and determine the quality. In testing honey's authenticity, the research team aims to help it retain its natural value and ultimately safeguard biodiversity. Specialized optical glasses, like those used in smart windows, are becoming commonplace in a variety of industries. But some of its key components are still a bit mysterious. Now, with a pairing of technologies in hand, researchers can explore in-depth glass composition and its effects on structure and functionality. A team from the Federal University of São Carlos and the University of São Paulo in Brazil are using a mix of nuclear magnetic resonance spectroscopy and computational modeling for a closer look at glass intermediate oxides, which tout unique optical properties within silicate glasses. Among those oxides under investigation is niobium, known for its own outstanding nonlinear optical properties and ability to enhance refractive indices of glasses for optical applications. Materials scientists currently use computational resources like machine learning software to design customized glass. The problem with that approach? A lack of systematic spectroscopy characterization data. Until now, this has kept the structural role of oxides like niobium unclear. The new method is helping the team better understand niobium oxide's role in silicate glasses in particular, which could ultimately advance customized glass design. What happens when you throw a weak laser into a frequency comb? Researchers based in Maryland are finding out. A team from the Joint Quantum Institute, a collaborative group from the University of Maryland, the National Institute of Standards and Technology, and the Laboratory for Physical Sciences, has designed and built brighter on-chip optical frequency combs based on dissipative Kerr solitons, self-organized optical waves resulting from the interaction between dispersion and a change in a material's refractive index when an electric field is applied. The new compact frequency combs can be tuned by injecting a weak laser into them, which then optimizes the power by more than an order of magnitude in numerous comb teeth. The combs emit a continuous train of short, closely spaced light pulses that can measure light waves as if they're radio waves. Technologies like atomic clocks and communications devices can then connect to optical waves that fluctuate at significantly higher frequencies, as much as 10,000 times higher than what are found in electronics. The researchers say these developments lay the groundwork for higher precision chip-based devices. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, and visit laserfocusworld.com for the latest and coolest news and information. Until next time.